Welcome. Today we're diving into two of the most powerful, and you'd think, opposite forces on a planet. On one hand, you've got explosive, fiery volcanoes that build mountains from scratch. And on the other, you have the quiet, slow, hidden world of groundwater that carves out entire systems right beneath our feet. They seem like total opposites, right? But as we're about to see, these forces of creation and persistence are surprisingly tangled together. So let's start with this puzzle. How can the very same planet create something as violent and destructive as a volcano, but also something as calm and life-giving as a desert oasis? Well, that's the big question we're going to unpack. And the answer connects the blazing hot surface of our world with its secret water-filled depths in a way you might not expect. First things first, let's look up. We're talking about the big, dramatic, and often destructive power of volcanoes. These are the landforms that literally erupt onto the surface, building the very ground that we stand on. Now, you might think all volcanoes are those perfect cone shapes, but not even close. It really all comes down to the lava's consistency. Think about it. On one side, you have this thick, gooey, acid lava that's so sticky it just can't flow very far, so it piles up and up, creating this steep-sided dome. But then you have this runny, fluid lava that just goes for miles, spreading out and forming a low, broad volcano that looks like a warrior's shield lying on the ground. This right here, this is pure geologic drama. It kicks off with a super violent eruption that throws out all this fragmented stuff. Ash, cinder, you name it. And since it's solid, it just piles up, making that classic steep cone shape we all know. But then, the lava can actually block the vent. Kind of like a cork in a champagne bottle, the pressure inside just builds and builds until, boom, a huge explosion literally blows the top off, leaving that iconic bowl-shaped dent we call a crater. And when that explosion is on a whole other level of massive, you get what's called a caldera. Now, this isn't just some crater. It's a gigantic collapsed cauldron. We're talking about a volcano so huge that after its top blows, it leaves behind a basin that can be miles wide, with these massive sheer cliff walls. And the coolest part? If that giant bowl fills up with rainwater over centuries, you get an absolutely stunning crater lake. Okay, now let's hit the fast forward button by a few million years. So an ancient volcano goes quiet. For ages, wind and rain just beat down on it, washing away the softer cone of ash and cinder. So what's left standing tall after all that time? Only the super hard lava that cooled and solidified deep inside the volcano's main type. This tough remnant is called a volcanic plug. It's pretty much the ghost of a mountain, the stone skeleton of a giant that once was. All right, time for a big shift. We're leaving the fire and brimstone of the surface, and we're heading down, way down, into the quiet, hidden world of water that's moving all the time, right under our feet. You know, every time it rains, that water soaks into the ground. But it doesn't just go down forever. It eventually reaches a point where the ground is totally soaked, completely saturated with water. The very top of that soaked zone is what we call the water table. And here's the thing a lot of people get wrong. It's not a perfectly flat, level surface. It actually tends to follow the shape of the land above it, rising up under hills and dipping down under valleys. And this water table isn't static, it's alive. It basically breathes with the seasons. During a rainy season, as more and more water soaks in, the water table rises up to its high point. But then, in the dry season, it falls back down to its lowest level. That whole area in between is this zone of flux that's only really wet during the rainiest times of the year. This breaks it down perfectly. The easiest way to think about it is to picture the ground as a giant sponge. The very top layer is mostly dry. That middle layer, the one we just talked about, it gets soggy after a good rain, but it can dry out. But that bottom layer, the zone of permanent saturation, that part is always, always soaked. That's where our main supply of groundwater really lives. So we know the water is down there, but how in the world does it move around? It's not some big underground ocean. No, it's way more like a complex, three-dimensional maze, and the type of rock determines all the paths, doorways, and dead ends. Let's see how that works. Okay, pay attention, because this part is absolutely key. Porous and permeable. They sound similar, but they are worlds apart. Porous just means a rock has tiny holes or spaces in it, so it can hold water. But permeable means those little holes are connected, so water can actually pass through it. Sandstone is the perfect example. It's basically a superhighway for water. But then you look at clay. It's porous. Sure, it can hold water, but it is not permeable. Water gets in, and it gets stuck. It's a total dead end. This simple difference is what creates all the underground reservoirs and barriers. We've seen how water gets in and how it navigates that rocky maze. So now for the final piece of the puzzle. How does all this hidden water make its way back to the surface so it can interact with our world? Well, the simplest way is a spring. And really, all a spring is a place where the land dips down low enough that it literally cuts into the water table. The water, well, it has nowhere left to go, so it just flows right out onto the surface. It's the moment the hidden underground world becomes visible. But sometimes the geology gets way more interesting. Picture this. You've got a layer of that permeable sandstone, that water highway we talked about, but it's trapped. It's sandwiched between two layers of that impermeable rock, like clay. This really special setup is called an artesian basin. And that critical water-holding layer, the permeable rock, stuck in the middle of that geological sandwich, it has a special name. It's called an aquifer. And you gotta understand, aquifers are one of the most important sources of fresh water on the entire planet. They're like these massive, natural underground reservoirs holding incredible amounts of water. And here it is. This is the incredible payoff that brings us right back to our first question: what happens when one of these aquifers exists deep under a desert? Well, over thousands and thousands of years, the relentless wind can scour away the top layers of sand and rock until eventually it exposes the water-filled aquifer below. And that is how you get an oasis, a pool of life-giving water in the middle of one of the driest places on Earth, all fed by a hidden underground river. So it all comes back to this. Volcanoes build the land with fire, creating the very rock structures, the basins, the different layers. And then, over millennia, water quietly filters down through it all, emerging in just the right places to create life. So it really makes you wonder,